Alright, 2010. This is the Maths Methods Exam 1. I'll go through my solutions. If you have any questions or if you find a mistake, leave a comment. As always, I recommend you have a look at the examiner's report as well as watching this to give you a better idea of what to do. So here we go. Question 1. You'll notice on this video I've included a percentage here. That's the percentage of people who got full marks for this question in that particular year. That's just taken off the examiner's report. So 79% done quite well. We're differentiating x cubed e to the 2x, so we're just going to use the product rule. If we differentiate x cubed, we get 3x squared, leave e to the 2x the same, plus differentiate e to the 2x, which is 2e to the 2x, leave x cubed the same. That would have been enough to get you the 2 marks. But you could factorize it if you wanted. I wouldn't necessarily do that, just in case you make a mistake, in which case you'll lose the marks. Alright, part B, log of x squared plus 1. To differentiate that, we'll need to use the chain rule. If you differentiate what's inside the brackets, you get 2x. So the chain rule will give you 2x times 1 on x squared plus 1, which is just the same as that. And if we sub in 2, we simplify to get 4/5. Moving on, find an antiderivative of cos of 2x plus 1 with respect to x. Very, very easy question. If we differentiate what's inside the brackets, we get 2x. So to anti-differentiate, we do, sorry, not 2x, just get 2. So 1 on 2 comes out the front, and then sine of 2x plus 1. You could just do a quick check, differentiate that again to see if you get back what you started with, in which case you'd be correct. So 76% got the mark there, very easy. Alright, part B, we've got a definite integral here. So if we anti-differentiate 1 on 1 minus x, we get negative log e of 1 minus x. Make sure we use our modular signs here. Just leave my log of p on the other side. Sub in 3, sub in 2. Be careful to use lots of brackets. Keep those modular signs going. If you sub in 3, you get 1 minus 3, which is negative 2. You sub in 2, you get 1 minus 2, which is negative 1. So this is where those modular signs will come into play, because the negative 2 would just become positive 2, and same with the negative 1. Log of 1 is just 0. Negative log of 2 is the same as log of a half. So the log of 1 just disappears. We end up with log of a half is equal to log of p, so p must be 1/2. Only 30% got 3 marks there. Alright, question 3a, a composite function question. So basically, here's f of x, which is 1 on x squared, and we want to find g of x, which is given as f of x. So we're summing this function into itself, which is a bit strange, but what we get is 1 on x squared. If we sub in 1 on x squared in for x, g of x becomes 1 on x squared all squared, which is 1 on x to the 4, which is just x to the 4. Part B, we want to find g to the negative 1 of 16, where g to the negative 1 is the inverse function of g. So the inverse function is pretty easy. The inverse of x to the 4 is just the 4th root of x, or x to the power of 1 on 4, same thing. And you notice I put the domain here. The reason for that is so that gives me, when I sub in 16, I get 2. I don't get plus or minus 2. We're only considering where x is greater than 0. Now, did I need to put this here? I'm not really sure. It was only worth 1 mark, so it probably would have been okay just to have the answer. But don't quote me on that. Alright, question 4. Write down the amplitude and period of the function. Another real gift of a question, very easy. The amplitude is 4, and the period is 2 pi on 1/3. 2 pi on 1/3 is 6 pi. 64% got that right. I'd say the people that got it wrong probably stuffed up the period. Alright, and then part B, solve the equation root 3 sine of x is equal to cos of x between negative pi and pi. Simplest way to do this, if you've got a sine on one side and a cos on the other side, divide both sides by cos. So sine divided by cos gives you tan, and cos divided by cos is just 1. So you end up with root 3 tan of x is equal to 1. And if you divide by root 3, that gives you my first line here. Tan of x is equal to 1 on root 3 is very easy to solve. We get pi on 6 as our first solution, and then we need to be between negative pi and pi, so we'll go back the other way, giving us my other solution of negative 5 pi on 6. Okay, question 5. Let x be normally distributed random variable, mean of 5 and a variance of 9. That would be people's first mistake there, would probably not read that carefully and see that we've been told the variance, not the standard deviation, but we'll get to that down here. So all we've been asked for, first of all, what's the probability that x is greater than 5? Well, if the mean is 5, then the probability x is greater than 5 is just a half. Very easy. So most people got that. But then find b such that the probability that x is greater than 7 is equal to the probability that z is less than b. So what we had to do here was, first of all, realise that we were given the variance and not the standard deviation. So the standard deviation will be 3. So if we find the z score for 7, we get 7 minus 5 on 3, which is 2/3. So I've just drawn a diagram down here, which I didn't need to do, but just shows you a little bit better. So here's my x with a mean of 5. So the probability x is greater than 7 will be that area there, and that corresponds to a z score of 2 on 3. So the probability that z is greater than 2 on 3 is the same as the probability that x is greater than 7. But we want z is less than b, so we're talking about this area down here, which would just correspond to negative 2 on 3. So the probability that x is greater than 7 is the same as the probability that z is less than negative 2 on 3. So that gives you b. Okay, moving on. Question 6 was probably a question was done quite poorly, as you can see. I think matrix transformations tend to scare people off a little bit. The question was worth 3 marks, and we're given a lot of lines, so it's a fair bit of work that needs to be done, but if we take it in steps, it's not actually too difficult. So if we actually multiply these matrices out, we can find what's happening to our x and our y, what these transformations actually doing. So what we do is we write x dash, which is what my new x is, which is 3x minus 1, which is what happens if I multiply these matrices out. So 3 times x minus 1, and this gives me 2 times y plus 4. So my new x is 3 times my old x minus 1, and my new y is 2 times my old y plus 4. And if I rearrange those in terms of x and y, I get x dash plus 4 on 3 and y dash minus 4 on 2. So once you've done that, all you have to do is take your original function, which is y equals 2x squared plus 1, and instead of y, sub in y minus 4 on 2, and instead of x, sub in x plus 1 on 3. So we'll leave our dashes here. Once you've done that, it's just a matter of rearranging this, expanding and simplifying so that we can get it into the form ax squared plus bx plus c. So if we take our 2 to the right hand side and we add 4, that makes this 4 times x plus 1 on 3 all squared plus 2, and then we add 4. So I've done that, but at the same time my x plus 1 on 3, I've changed it to a third x plus 1 on 3. That's just going to make this easier to expand. So if I expand that, I get 1 on 9x squared plus 2 on 9x plus 1 on 9 plus 6. Multiply that all by 4. Find a common denominator just for this part here. So 6 times 9 is 54. So 4 on 9 plus 54 on 9 is 58 on 9. And here's my transformed equation. And here's my A, my B, and my C. And I'm done. Don't be surprised if in the first exam you get answers that are quite messy with fractions or surds. It doesn't necessarily mean you're wrong. Quite often the answers are just messy ones like that. Question 7, we've got a continuous random variable. So we should know enough about probability to know that the area under this is going to be 1. So therefore the integral from 0 to 5 of ax5 minus x has to be equal to 1. So if we evaluate that integral, and solve for a, we have our answer. So easiest thing to do here is take the a out the front and expand this, so that gives you 5x minus x squared. Anti-differentiate, you get that. Sub in 5, sub in 0, simplify, common denominator, solve for a, you get a is equal to 6 on 125. Just with these integration questions, don't forget your dx's, that will come up again very soon. Express x is less than 3 as a definite integral. Pretty easy. Sub in our answer for a, and it's the area from 0 to 3 of that. Okay, we've got a discrete random variable now. Find the value of p. So we should know enough to know that if we add these four things up, they should equal 1. So p squared plus p on 4 plus 4p plus 1 on 8 is equal to 1. So play around with that. Take everything to the left. When I got to this line here, I multiplied everything by 8 just to get rid of those fractions. So that gave me 16p squared plus 6p minus 7 is equal to 0. Factorize that, you get 8p plus 7, 2p minus 1. Worst case scenario, if you can't figure out how to factorize that, just use the quadratic formula. You should get the same answer, negative 7 on 8, or p is equal to 1/2. Now, p has to be greater than 0, so we cross out that solution and state why we've crossed it out, and then we're just left with our answer of p is equal to 1/2. Make sure you do that, cross out the answer that you don't want. Okay, two more questions. So this one here, we've been given part of the graph of x log of x, and the first part of the question they've just asked us to differentiate this, so x squared log of x. Just using the product rule, we get this 2x log of x plus x. So there was a product rule question earlier, so I'm not going to explain that again. Now, using your answer to this, we want to find the area of the shaded region. So the key here is to use this answer. So this answer would tell us that if you anti-differentiate 2x log of x plus x, you get what we started with at the start of that question. Now, the way that it helps us is that in order to find the area of the shaded region, we need to evaluate the integral from 1 to 3 of x log of x. So if we can somehow change what we've got here to just the integral of the integral of x log of x, then we'll have an expression for the antiderivative of that, and we can find that area. So what we're doing here is we're going to break up this integral. So and we're going to took the 2 out the front here too, so this line here is the same as this line here. Okay, and then if we take this whole thing to the right hand side, so there's the integral of x dx there, and we halve the whole thing. The integral of x is 1/2 x squared, and we expand those brackets. What we have here is an expression for the antiderivative of x log of x. So if we've got that, we can then answer the question. So the area is given by the definite integral of this from 1 to 3, and we know what that is. So we put that into our square brackets with the terminals of 1 and 3, sub in 3, sub in 1, simplify, get it into the right form, and we've got 9 on 2 log of 3 minus 2. Okay, final question. Sorry, second last question. Alright, question 10. Just had to play around with some derivatives and some points here to get the answer. So if we're told that the line ax minus 1 is a tangent to this curve at the point 9c, then that means that if we differentiate this, we get 1 on 2x to the negative half, and we know that at the point 9, the gradient would have to be a, because the tangent to that curve at that point is ax minus 1, and the gradient of that tangent is a. So if we differentiate sub in 9 and let it equal to a, we get this. Solve for a, we get 1 on 6. Now we know that the tangent is 1 on 6x minus 1. And we know that the tangent passes through the point 9c. So if we sub in 9c, then we can solve for c, and that gives us 1/2. Then finally, if we take our original equation of the tangent, the actual curve, and we sub in 9 and 1/2, then we can solve for d, which is negative 5 on 2. Okay, final question. So we've got a cylinder which is fitted exactly inside a right circular cone. we're told that the height of the cone is 5 and the radius of the cone is 2 centimeters. The radius of the cylinder is r and the height of the cylinder is h. So what we're asked to do first of all is find h in terms of r. Now this is pretty tricky actually, as you can see only 11% got the answer. So I think the key here was to draw up this triangle here. So I've drawn that down here, and here's the cylinder, or half of the cylinder, and that length there is 2 and that length is 5. So what we're actually going to do is we're going to use similar triangles, and there's the small triangle there, and that would be the large triangle there. So that length there is 2 and that small length there is 2 minus r. That length there is 5 and that length there would be h. So using similar triangles, we can write that as h divided by 5 is equal to 2 minus r divided by 2, which is what I've done over here. That just gives us h is equal to 10 minus 5r on 2. So part B, we're told that the surface area of a cylinder is given by this formula here. We're asked to find S in terms of R. Now that's pretty easy if you had an answer for A, because all we had to do was sub in our answer for A in for H here. So that gives me 2 pi times R times 10 minus 5R on 2 plus 2 pi R squared. And if I change my 10 minus 5R on 2 to 5 minus 5R on 2, makes it a little bit easier. Expand that and simplify, I'm left with 10 pi R minus 3 pi R squared. Now, judging by the fact that 47% got this right and only 11% got the previous question right, I'm going to assume that they would award consequential marks here. And whatever your answer from A was, provided it was sensible, if you sub that in for H, then you could have gotten this mark. So there's a lesson for you if you need an answer to the previous question, even if you didn't get it, come up with something sensible and sub it in, and you may get a consequential mark. Alright, final question on the paper. Find the value of R for which S is a maximum. Clearly by the 10% here, a lot of people had given up from the fact that they didn't get the previous two. But all we had to do here was differentiate and set it equal to 0. So if I had an answer to the previous question, which is 10 pi r minus 3 pi r squared, you differentiate that, you get 10 pi minus 6 pi r, making sure we write ds dr here, not something silly like dy dx. We're talking about s and r. Set that equal to 0, you get 0 equals 10 pi minus 6 pi r. Solve for r, you get minus 10 pi on negative 6 pi, which is, the pi's cancel, which gives you 10 on 6, which is 5 on 3, and that's the end of the paper. So I hope that helped. Like I said, any questions, leave a comment, and I'll try to do a couple more videos soon. Thanks.